Now, today we will discuss the seventh question of our assignment. Seventh question is differentiate logistic regression and linear regression on the basis of hypothesis parameters and cost function. How gradient descent algorithm is used to optimize the parameter. First, we will discuss the linear regression versus logistic regression. The purpose of linear regression is used for regression tasks that is predicting contiguous outcomes, example price or temperature. Logistic regression is used for classification tasks predicting categorical outcomes that is spam, not spam, healthy or disease. Output range for linear regression is produces values in minus infinity to plus infinity. Logistic regression produces values in presenting probabilities like 0, 1, 1, 0. Decision rule for linear regression is direct output is predicted value. And for logistic regression, it is classified as 1 if this is the condition followed or else 0. Parameters for linear regression represent coefficient of the best fit line minimizing squared error. And for logistic regression, represents weight that define the decision bounding separating classes. The nature of relationship models linear relationship between input and output. And nature of relationship in logistic regression, it models non-linear relationship between input and log odds of output. Output interpretation in linear regression is predicted value itself, example 45.2. And output interpretation in logistic regression is probability of belonging to class 1, example 0.82, that is 82 chance of positive. The gradient descent algorithm. Purpose of descent algorithm is used to find optimal parameter values theta that minimizes the cost function. First step is initialize parameters. Start with random values of theta 1, theta 2, theta 3, and so on till theta n. Second is compute the cost function. Calculate j theta using respective cost function for linear regression, log loss for logistic regression. Third is compute the gradients. Compute the partial derivative of the cost function with respect to each parameter. Fourth, update the parameters. Update each parameter in the direction of negative gradient where alpha is the learning rate, controls the step size. Fifth is repeat until converges. Iterate steps 2, 4 until the cost function changes and reaches